Hi, my name is Alieski, professor of the University of Informatics Science in Havana, Cuba. I am going to present to you a research work approach of immersive adaptive learning for virtual reality simulator. The introduction of novel technology benefits fields such as medicine, education, and industry. The use of virtual learning environment has become a complement to first class at different levels of education. However, it will be better used if they constitute immersive environments. Some studies show that achieve greater motivation in students it is necessary an immersion degree of student. In this sense, the application of virtual reality plays a fundamental role. Virtual reality takes place in a safe environment that allows reconstructing the surrounding reality and control the different stimuli to which an individual is subjected. In this direction, other concepts are involved such as immersive learning and adaptive learning. Adaptive learning system is a learning model based on technology that can detect the student's individual situation, context, learning needs and style, and the state of their learning progress dynamically and act according to them. Some elements to consider on the system are data collection, feedback, data processing, content interaction, learning progress, content adjustment, among others. Immersive learning is the process of learning with the use of stimuli environment that allow a student to connect a real experience within safe environment. So, this experience, motivation and commitment to the activity being undertaken increase and leaves an impression of the student psyche to favor the memorization of the content. Virtual reality applied in different contexts and reached an important place among current technology. Virtual environment create a safe environment without risks and allows skill to be developed through repetition. A common problem with virtual reality system that the user experience the same training routine, as these virtual reality systems are not customized for individual learning patterns. Virtual reality simulators can be adapted to the capacity of the user. Adaptation occurs through active devices and other accessories that allow movement and other functions. Another type of adaptation takes place through the software with the content and user interface adjustment, supported by the use of stereoscopic device and hand controller. Basic elements of virtual reality-based training simulation include active device, autonomous agents, adaptive technology, feedback and evaluation and classification, and head-mounted display. With the evolution of adaptive technologies in the field of virtual reality, the areas of application of virtual training systems are increasing also, highlighting the area of medicine, education, dual commerce, and the military industry. The self-adaptation of virtual reality systems as well as adaptive learning platform requires the processing of user data records. Based on a study in the field of adaptation, virtual reality system conducted two elements of adaptation, highlighting user performance, active feedback, difficulty adjustment, objectives, emotion, user interaction, optimization. In application areas such as education, military training, vehicles driving, and others. Those studies are based on framework approach or basically the development of the system with those features. Feedback should be done in real time, otherwise it could be led to more errors if could will only be known at the end of the training. The system needs less optimization when the knowledge base about the user is enhanced. Our approach is structured in three main components: a user model, virtual reality scenario, and adaptation engine. The user model is based on important elements to know how to classify user based on different variables. User model provide user characteristics split in three main collections: skill and knowledge, emotion, and behavior. User model is in constant interaction with the other components and help to understand the user has difficulties at some stage of training. Taking a surgery simulation as a sample, a normalization study with user groups influences the configuration of the user model. Considering three user groups performing procedures at different skill levels can provide the simulation with a starting point to compare training results. For adaptation engine, to know what to do and make decisions and next steps. On the other hand, the adaptability engine depends on the data processing that is collected from the user model. A user ranking algorithm places the user into groups based on the similarity of the skill. In this way, the adaptation engine adjusts the content and optimizes for user groups rather than independently. The content adjustment relies on highlighting visual elements, playing audio or other signals that not cause too much noise in the environment, so that the user is not disoriented from the activity. The simulation makes decisions based on the combination of variables that allow to establish rules, observing the behavior and the user, and being able to create behavioral patterns that favor the adjustment of the difficulty. So, in order to understand the stage, the input variables corresponding to the user model are configured in the configuration stage and prepares the environment for training. A simulation without previous information will need an initial configuration validated by experts and that indicate the adequate average value of variables such as task execution time. For example, the appropriate average value of task execution time variable in a surgery simulation should be validated by expert surgeon from the average time to perform a procedure in real life and the estimated average time to perform the same procedure in simulator with the intervention of controller. In this sense, haptic gloves are preferably as controller due to it provides more realism in the interaction compared to button controller. And the first training in simulation starts from the initial configuration of the user model variables. This calibration training or adaptive training allows the user to become familiar with the environment and acquire skill with the controller. In the stage of measurement, this stage is the training result and involves a user classification algorithm according to the skill acquired from the data processing of information recorded during the training. A classification algorithm will place the user in one of the groups, beginner, intermediate, or advanced. The user will move through these groups according to progress in the training, placing the students in groups that represent their level of training. This group could be considered for the transformation and adjustment of the content. So, as final consideration, the user characteristics must be considered to produce an appropriate adaptation. Better conserved user models are needed in order to achieve a better adaptation of the simulator. As future work, the author of this investigation did this component further to arrive at an adapted model for virtual reality simulator. So nowadays the author of this research are working on the development of a model that integrates the elements of this approach to achieve the adaptability of simulation for surgical training. That's all. Thank you so much for your attention.